Welcome, dear students. So, in our series of lectures on novel drug systems, the subject paper we are dealing, we'll be discussing the rest of the part of the pulmonary drug delivery systems. So far, in pulmonary drug delivery systems, we studied that what are aerosols, what are pharmaceutical aerosols, API, dissolved, emulsified or suspended in propellants, and with the valve mechanism they are released in the form of mist or spray to have the precise action. We have studied the advantages and limitations of pulmonary drug delivery system or aerosols and studied various types of aerosols on the basis of routes of administration. Now we have covered the basic concept of aerosol in the last part. Now in this lecture we are going to discuss the components of aerosols, pharmaceutical aerosols. Let's discuss this aspect in this lecture. After completing this lecture, you will be able to compare the properties of different propellants and you will be able to select propellants for aerosols. You will be able to classify container types. The lesson will be covered under the heads propellants, the concept of propellant, classification of propellants, nomenclature of propellants, advantages, limitations, uses, container and material types. So let's start our discussion with components. First of all, many times it is asked whenever there is a question in the pulmonary drug system, the definition is asked, number one, the advantage limitations is asked, and the components are asked, and one of the component may be asked in detail out of that. Okay, so there are four components as you can see here. The propellants, okay, these are the propellants, container, valve and actuator, and product concentration. So these are four components. Okay, propellants are heart of an aerosol package. They are the driving force behind any aerosol system. They develop pressure and expel or dispense the product through the valve when opens. It's a dispersion medium. Propellant is a dispersion medium as well as the driving force providing for dispensing or discharge of product from the container. So always remember that it is a driving force, okay, and heart of an aerosol package. So let us see what are the types of propellants: liquefied gas and compressed gas propellants. There are two major types, LG and CG, liquefied gas propellants and compressed gas propellants. Liquefied gas propellants can be classified into three classes: hydrocarbons, chlorofluorocarbons, and hydrofluoroalkanes. They are abbreviated as SCs, CFCs, and HFAs respectively. So you must remember this classification. Now let's move to the propellants. That if you compare the liquefied gas propellant and compressed gas propellant, as you can see in this part, that in the liquefied gas propellants, propellant vapors and liquid propellant and product is mixed together and propellant vapors are on the head portion. Okay, in this portion, in the above portion of this propellant vapors are there, while in the case of compressed gas, the compressed gas is not mixed with product. Okay, compressed gas is here, as you can see in the upper part, okay, in this part, here we can see this the compressed gas in the above part and the product in the lower part. Okay, so this you can see. So this is the difference. Now let's discuss the liquefied gas. Propellant are in gaseous or vapor state. In liquefied gas, you can see it can be liquefied. When you are talking about the liquefied gas, the gas can be liquefied at relatively low pressures or temperatures. In liquid state, in pressurized package, they are used in aerosol. So gas, when they are liquefied in pressurized package system, they are called liquefied gas propellants. Okay. They are partly in vapor state and in the head space. In the liquid, just like you can see your LPG cylinders, liquefied gas cylinders, LPGs. Okay. How it functions? What is the function? When you open the valve, some propellants in vapor state is mixed with the product for helping in spray formulation and dispense with the product. Some of the liquid propellant immediately automatically convert into the vapor and compensate the vapor propellant mixed and discharged with the product concentrate. So by this way, it expels the drug content out of that package system. Take this example. As you can see, we have shown the vertical section of a pressurized package system aerosol. As you can see, the gaseous propellants is exerting the pressure, and here in the case of liquefied propellant, which becomes what happens that liquefied propellant mixed with product and it helps in spray formation. By the product concentrate, solvent and liquefied propellant, they may be in two phases here in the with the product. So what is the beauty that the liquefied gas propellant final pressure is equal to initial pressure throughout the shelf life. Actually, what is happening whenever there is a loss of some by this with the head space in the head space, when there is a loss of some vapor, then some liquid is converted into the vapor form and the pressure remains constant. Okay, this is the prime property of a liquefied gas propellant, and it is many times asked, especially in the GPAT examinations, that what is the difference between the compressed gas and the liquefied gas propellants with respect to this thing, or the question may come clockwise or anti-clockwise in any way, but the main point is that final pressure is equal to initial pressure, that initial pressure throughout the shelf life in liquefied gas propellants. Remember this thing. Now what are the types of liquefied gas propellants? Hydrocarbons, CFCs, hydrofluoroalkenes. We have discussed. Now we will move one by one. Hydrocarbons examples include N-butane, isobutane and propane. So these are the major examples. Advantages of hydrocarbons: they are cheap, cost effective, they are safe to ozone, they don't have ozone depleting effect, unlike chlorofluorocarbons we will be studying ahead. They exert negligible greenhouse effect, excellent solvent they are, and they expand well. They have the large expansion ratio. Why it is required? Because when we are spraying it, a spray must have a good expansion ratio when it is coming out of that that nozzle. So it should have a good expansion ratio. Okay, that expansion, it should have a good expansion ratio so that spreading may be more and more. And this is an advantageous found, a beneficial feature of hydrocarbon. What are the limitation or disadvantages? They are flammable, they have the aftertaste, they may be toxic following inhalation, and they use liquid density. they have got the low liquid density. Okay. Now coming to the CFCs, chlorofluorocarbons. CFC is 11, it is CCl3F, CFC12, CCl2F2. Okay. Difluoromethane or CFC114. Okay, chlorofluorocarbon 114, C2Cl2F4. Now we will study also what is the numbering system means. You are saying that it is what is the numbering? How you can say that? Let's see the thing. How we can nomenclate? We give the name. What is the nomenclature? The American Society of Heating, Refrigerating and Air Conditioning Engineers, ASHRA. This organization created a standard for a halocarbon numbering system. Generally, they are very big in, they are having very big names, so they wanted to have a handy name for their use. So they designated uh, the name with 3 digits followed by an alphabet if required. Okay. Now let's see what these 3 digits mean. Nomenclature for CFCs and hydrofluoroalkanes is done by this. In first digit equals to number of carbon in the structure minus 1. Okay. So if if there is only one carbon, the first digit will be 0. Okay. So the entire digit will be only the 2 numbers will be there. The first digit is 0. If it is 2 carbon is there, then the first digit will be 2 minus 1, 1. Okay. Second digit, number of hydrogen atoms plus 1. Number of hydrogen atoms plus 1. It means if hydrogen is not there, then the second digit will be 0 plus 1, 1. If it is 1 hydrogen there, then it will be 1 plus 1, 2. And third digit is number of fluorine atoms in this structure. If 1 fluorine is there, 1 will be the answer. If 2 fluorine are there, 2 will be there in the third digit. So 3 digits will be there. Okay. Now what about the remaining atoms? All remaining atoms are assumed to be chlorine atoms. They are assumed to be chlorine atoms, and initial 0 means, if there is initial 0, it means it indicates a 1 carbon compound and it is omitted when we are saying the name, like CFC12. It means it is CFC012. More symmetric structure is designated by numbers only, and as the asymmetry increases, you add on A, B, C, etc. following the number. Okay. So take the example. This is the name of the structure of a propellant 111233 heptafluoropropane. So it has 3 carbon atoms. So what will be the first digit? Number of carbon minus 1. So 3 minus 1, 2 is equal to 2. Okay. So the first digit will be 2. Now it is having 1 hydrogen atom. So second digit will be 1 plus 1, 2. It has got heptafluoro. It means 7 fluorine atoms. So third digit will be 7. So, and what is the next thing? And there are no chlorine atoms. Therefore, it is named as HFA227. It is HFA227. In the same way, you can see the number, the CFC114. What is the CFC14? Actually, CFC1, you can vice versa, you can use it. If first digit is 1, it means number of carbon is 0. Okay. Number of carbon minus 1. Sorry. Number of carbon minus 1. So, meaning number of carbon are 2. So, it is ethane. And second digit 1, it means number of hydrogen is 0. So, CFC114 is actually dichlorotetrafluoroethane. Okay, tetrafluoro 4 fluorine. So third digit will be 4. CFC12 or 012 precisely, difluoromethane. It is having difluoro. It means 2 fluorines are there, so it will be a third digit. Okay, and it is methane. So C minus 1, number of carbon minus 1. So first digit will be 0. Okay, number of hydrogen is 0. So 0 plus 1, 1. So CFC12 is difluoromethane. So you will have to learn that how you can give the name or how you can have the identification of the propellant by seeing the name or vice versa. Okay. Now, what are the advantages of chlorofluorocarbons? They are less toxic upon inhalation. They have high chemical stability, high purity, and CFC11 is a very good solvent. Disadvantages of chlorofluorocarbons: high cost. They contribute to greenhouse effect. Ozone depleting. They are not environment friendly. They deplete the ozone layer. Okay. So that's why they are being phased out by the hydrofluoroalkanes, and they have been banned by many countries, except they're used in some essential medicines still allowed in case of bronchodilators, ergotamine tartrate, certain topical antibiotic sprays, and contraceptive vaginal forms. Though there is a huge number of entry of new propellants which have replaced almost completely all the CFCs. Okay. So it is always asked in the question in the examinations. You are expected to tell about the CFC that they are not environment friendly. They deplete the ozone. Okay, as compared to other propellants. They show detrimental effect on Earth's ozone layer. The Montreal Protocol on substances that deplete the ozone layer in January 1989 set a timetable for elimination of chlorofluorocarbons. So the elimination was well planned in 1989. So that's why they have been replaced by the hydrofluoroalkanes. Now, these hydrofluoroalkanes are becoming an good alternate. They have less detrimental effect on the environment. CFCs are exempted, as we have mentioned, for only few classes of aerosols like Ndds for oral or nasal steroidal drugs, bronchodilators, ergotamine tartrate, as we mentioned, in case of migraine, and certain topical antibiotics, sprays, and contraceptive vaginal forms. We have discussed it. Now moving to the hydrofluoroalkanes. So they have got very much importance because they are replacing the chlorofluorocarbons, CFCs. 111233 heptafluoropropane. We discussed this nomenclature in the example. Remember, it is HFA227. Many times it is asked that what is HFA227. So it is replacing basically the CFCs. So you will have to give the complete structure on the basis of that nomenclature. 1112 tetrafluoroethane. It is HFA134A. Okay, it is one of the best alternative. These two, HFA227 and HFA134A, are the best alternatives of the chlorofluorocarbons. What are the advantages? They are less toxic on inhalation. They've got the high chemical stability and high purity. So overall, they are very much effective and they've got many advantages over the chlorofluorocarbons. And the most important point is they are environment friendly. They don't deplete the ozone layer. When CFCs are substituted by HFAs, the global warming potential is reduced by more than 75%. So very big help to the environment. The total global warming contribution of HFA MDIs is less than 0.5% of the total greenhouse gas emissions. So that's why HFAs are replacing the CFCs, chlorofluorocarbons, to protect the environment. Hydrofluoroalkanes, they have got the limitation that they are expensive as compared to the CFCs. They are not very much good solvent. They are poor solvents and they exert minor greenhouse effect. Though they don't have as much as effect as the chlorofluorocarbon is showing, but they have the effect. Okay. Now let's move to we have discussed the chlorofluorocarbons, hydrocarbon chlorofluorocarbons, HFAs. They are all come under the category of liquefied gas propellants, which is one type of propellant category. Now we are moving to the compressed gas. What are the examples? Carbon dioxide, nitrogen, and nitrous oxide. They are compressed gases. They are not costly. They only occupy the head space. They have the less inhalation toxicity, high chemical stability and high purity is available with the advantage of no environment hazard. They are environment friendly. Okay. Limitations of these compressed gases or disadvantages, they are non-volatile. Co-solvents are required to be used when we are using them as a propellant. They expand, their expansion is less, they expand less, they have got the little expansion ratio. Okay. So as you might have seen in some perfume bottles, the perfume is splitted in just like a few drops, okay, like it is tap water, like you say, and in some spray is very good, okay. So expansion ratio, good expansion ratio is prime requirement for a aerosol system. They produce coarse droplet sprays, okay, because they have got the less expansion ratio. Use is limited to applications where type of spray is not critical. When the mode or type of particular spray is not critical, you can use it as a very cost-effective alternative, like in case of dental creams, hairspray, germicide, etc. Now, how it works, how the compressed gas based aerosol works. When you open up a valve, the gas pushes the liquid and products is dispensed. Now the remaining amount of gas has more space to occupy in head space. Okay. So after use, the pressure drops. The pressure drops and goes on decreasing with the passage of time during use. So this is the drawback. That compressed gas propellant with the shelf life, with the product shelf life, the pressure goes down. Now we discussed the all kind of propellants. Now it's a time to move to the containers. Now these propellants and containers must be compatible enough. Now let's see this table. Container, maximum pressure and temperature. When in case of tin plated steel, the maximum pressure it can withstand of 140 to 180 psig with the temperature of the 130 degree Fahrenheit. In general, the container must withstand pressure up to 140 to 180 psig pounds per square inch gauge at 130 degree Fahrenheit. This is the standard condition, you can say. But in case of aluminium, it can withstand up to 180, 130 degree Fahrenheit, and stainless steel up to 180 with 130 degree Fahrenheit. Plastics less than 25 psig, 70 degree Fahrenheit. Uncoated glass can only withstand a pressure of less than 18 and a temperature of 70 degree Fahrenheit. Coated glass, however, can have a little more. It can withstand little more pressure, and but only up to less than 25, and the temperature same 70 degree Fahrenheit. Now you must learn this table. It is very easy way to present, because otherwise when you are writing it in the lines and words, it will be very typical, and this presentation will save your time. You have said the thing in a tabular form rather than saying in the text, so it will save your time in the exam. Okay, for exam point of view, remember to present the thing in the infographic way. Use more and more infographics, ray diagrams, tables. It will save your time, and the presentation will be better. Now, what is a tin plated steel? Tin plated steel is light and inexpensive. When we are using as a container of a aerosol, it may be coated with organic coating of for additional protection against corrosion. Like what kind of coating it may be? It may be oleoresins, phenolics, vinyl or epoxy coating. Coating also solves the compatibility issue. When you coat it, the internal structure when you are coating, the intimate contact of propellant and the container won't affect the overall quality or the performance or the stability of the entire aerosol system and the drug delivery. And they are used in topical pharmaceutical aerosols, tin-plated steel, as you might have seen your painkiller sprays. They are made up of tin-plated steel only. Aluminium, it is less reactive, lightweight it has as compared to steel. It is seamless, easy to fill and crimp, and shows greater resistance from corrosion, visually appealing it is, and incompatible. The aluminum is incompatible with some propellants and solvents, so it may be coated with any kind of organic coating which may provide the protection, and it is used in oral, topical, and most MDIs, meter dose inhalers. Let's move to stainless steel. We studied tin plate steel, then aluminum, then we are coming to the stainless steel. Stainless steel are the extremely strong, resistant to they are resistant. They have got the resistance to with the against the most of the materials. No extra coating is required. They are used in smaller sizes only due to high cost and production problems. They are used for inhalation aerosols, as you might have seen, because using the important point here the net that it is expensive. Obviously the mechanical strength is very good, but it is costly affair. Now coming to the glass is had got a very aesthetic value, and they have got no compatibility issues. They allow the visibility of content. You can see the container which is made of glass. And that's why you might have seen the for aesthetic values for all the cosmetic product perfumes are in glasses. Okay, so that it is visually appealing. Uh, for products with lower pressure, only you can use it up to 25 psig, and lower percentage, about only up to 15% of propellants can be used if you are using glass as a container material. Plastic coated glass is used for avoiding shattering only. It is just providing little bit more protection, or can give the little bit more mechanical pressure bearing properties. They are used for some topical and MDI aerosol meter dose inhalers. We will be covering this. What is meter dose inhalers? Basically, it is about metering the dose, so that each and every time when a dose is delivered, it is metered. If say for example only 20 microliter is to be delivered, only the 20 microliter will be delivered, not 21 or 22. The precision is very good in case of meter dose inhalers. Now moving to the plastic. Plastic is cheap, durable, lightweight, and it is used in small size. It can withstand lower pressure as compared to other aluminium, steel, glass, even the less than you can say in the range of less than 25 psig at 70 degrees Fahrenheit. It is incompatible with some solvents. Plastics are incompatible with some solvents. You will have to take care what kind of solvent you are taking when you are preparing an aerosol system or aerosol manufacturing you are doing. They are used for nasal sprays, rectal sprays, and vaginal sprays. Okay. Here you can refer the Banker Notes and Altons, and so many books are there. Essential of Pharmaceutical Technology. Let us summarize that what we have learned so far. Propellants are the heart or the driving force of aerosols. They are the drivers. Okay, remember they are the drivers. They have got the driving force. They expel the product out of the component. So they are pressurized in the pressurized package system. They may be of two types: liquefied gas and compressed gas. And liquefied gas may be of three types. They may be hydrocarbons, chlorofluorocarbons, and HFAs. Okay. Chlorofluorocarbons are being phased out by the HFAs, hydrofluoroalkanes, and these CFCs and HFAs can be given the name by the three-digit system: number of carbon -1, number of first digit, number of hydrogen +1 second digit, and number of fluorine atom third digit. Most symmetric one without any alphabet, and as the symmetry increases, the alphabet ABC follows with this three-digit system. Okay, and HFAs are preferred due to their environment friendly nature over the CFCs, and CFCs are being replaced only allowed to certain classes. So compressed gas propellants are cheap, but pressure is not maintained with the use. As far as the containers are concerned, containers are tin-plated steel, aluminum, stainless steel, plastics, glasses, and the selection of container depends on what kind of propellant you are taking, what kind of solvent you are taking, what kind of overall system it is, what kind of stability is required, how much pressure it can withstand, how much percent of propellant you are adding, because you cannot add higher percent of propellant in the glass, okay, or maybe in the propellant it is ranging from up to 15% of propellant as we have discussed. So remember that the selection of the container is should be done very carefully, taking care of these aspects. In our next lecture, we will be discussing the components and other materials and wall types, walls of this aerosol system. Please remember these classification is very important with respect to exam point of view, that classification of propellants, nomenclature of propellants. So you must know these two things essentially from exam point of view. So this was all for this lecture, and we'll be coming up with the more lectures on the pulmonary drug delivery systems. In the next lecture, we'll be meeting you with more details. Thank you. Thank you for being with us. Happy learning.